Hey everyone, in today's video we're going to dive into solving some equations. Right now we're on page 29 of the binder. It should say 1.1 solving one-step linear equations at the top. So we're going to cover a few things like what does it mean to solve an equation, how do we identify if something is a solution, how do we use inverse operations to solve an equation. But let's look at a couple things here first on this page. It says, what is an equation? So it's a mathematical sentence where one side equals the other. Below, we've got a few examples. 4 plus 8 equals 12. That's true. 12 equals 12. 2x plus 7 equals 5. 3x squared minus 4x plus 1 equals 0. Those have x's in them, so we would need to know what x is to make sure that it is a true statement. So what does it mean to solve an equation? It means using inverse, I-N-V-E-R-S-E, using inverse operations to isolate the variable. What does isolate? It means like get by itself, or get alone, the variable. And so, and find the solution. So let's talk. What is a solution? Well, in an equation, the solution is the variable, or the value of the variable that makes the equation true. Makes the equation true. And so when I say we're going to use inverse operations, what does that mean? Well, inverse operations are mathematical operations that undo one another. So if you think about like what undoes addition? It's subtraction. They're opposites of each other, or inverses. So subtraction. Addition and subtraction are inverse operations. And what's the inverse operation of division? Well, it's multiplication. So that's what inverse operations are. Let's turn to page 30 and try a few problems. Alright, so I'm at the top of page 30 now, where it says examples using addition and subtraction to solve an equation. So in example 1 here, I've got the equation x plus 6 equals 10. We need to think about how do we get the x alone by using an inverse operation. So you're going to draw a line. I like to draw a line down by the equal sign. It splits the equation in half. And to undo the plus 6, I want a minus 6. The inverse operation of addition is subtraction. So I'm going to minus 6 there. But whatever I do to the left side, I have to do to the right side to keep it balanced. And so now I have x, 6 minus 6 cancels out, equals 4. And there's my answer. Now if you think about this, if we go back to our original equation and we want to check it, does 4 plus 6 equal 10? If I replace the x with a 4, 4 plus 6, does that equal 10? Of course, it does. 10 plus 10 equals 10, so we are happy that is the correct answer. So let's do the same thing on number 2. Draw a little line by the equal sign, and now you're going to think, what inverse operation would get rid of the minus 3? Well, I need to undo it, so I'm going to plus 3. And I'm going to do the same thing to both sides. Okay, and now when we do that, we get y, and the minus 3 and the plus 3 cancel out, equals 8. And there's our answer, y equals 8. You can kind of check this in your head too. Go back to the original, y minus 3. Does 8 minus 3 equal 5? Yeah, it does. In number 3, I have 3 equals x plus 5. Ooh, this time the x is on the right. That's okay. So I'm going to draw my line again. This time to undo positive 5, x plus 5, I have to subtract 5. Whatever I do to the one side, I have to do to the other. 3 minus 5, I have 3, I take away 5, that gives me negative 2 equals x. You can leave it like that. Some people prefer to switch it around and say x equals negative 2. That works as well. Okay, let's try number 4. 7 plus x equals 11. Okay, so here's a habit we're going to get into. We're going to rewrite this. If the x doesn't come first, we're going to rewrite it. So that 7 is really a positive 7, and it's a positive x. So I can switch their order, and I'm going to put the positive x first, plus 7 equals 11. And now when I solve this, undoing plus 7, I do minus 7. And we're going to get x equals 4. Now when we go to rewrite number 5, it's negative 8 plus x. So the x is positive, but the 8 is negative. So when I switch them, what we're really kind of doing is reordering it like that. So now it's going to be positive x, so just x, and negative 8, so I'm going to write minus 8 equals 20. And then I can draw my line. X minus 8, I know I should add 8 to both sides. And that gives me x equals 28. Okay, let's look down at the very bottom of this page for a quick second. Anytime you see a problem like number 13 or 14 or 15, we're going to rewrite them. Okay, because in Algebra 1, we kind of want to get out of the habit of saying y plus negative 5. Instead, that's the same thing as really saying plus a negative is the same as minus. Y minus 5 equals 2. And then add 5 to both sides. We get y equals 7. It helps you know what to do, because when it's written like plus negative 5, or wait, do I add, do I subtract, what's the inverse operation? But when it's written as y minus 5, you know, I'm going to add 5 to both sides. 14. X minus negative 3, I always like to think of that as minus negative becomes plus a positive. You make them both positive. So it's really just x plus 3 equals 16. And now I know I should subtract 3 from both sides. And we get x equals 13. And finally, number 15. 40 minus x, or 40 equals x minus negative 40. So once again, I'm going to change that minus negative into plus positive. So 40 equals x plus 40. And if I subtract 40 from both sides, on the left side on the right side I just get x, but on the left side it cancels out 2. What number do I get if I cancel something out? You get 0. So 0 equals x, or x equals 0. Alright, let's turn to the next page. So on the last page we used addition and subtraction to solve equations. Now we're going to use some multiplication and division. Same idea, so let's look at 16 here. Negative 4x equals negative 20, and have your calculator nearby if you need it. Negative 4x equals negative 20. So when it's written like negative 4x, remember that means it's multiplication. Like negative 4 times x. So to undo that, I have to do the inverse operation of multiplication, which is division. So you're going to write like a fraction bar below. And I'm dividing by negative 4 on both sides. I want to leave the x there. I only want to cancel out or undo the negative 4. So now I'm left with x equals, and if you do negative 20 divided by negative 4 on your calculator, you get 5. And think about that mathematically. Does negative 4 times 5, if I plug in the 5 there, negative 4 times 5 is negative 20. Okay, 17. Draw my line. And this is 12 times y. So I have to undo that by dividing. I'm going to do division on both sides, and I'm going to divide by whatever is multiplied by y. So I'm going to divide by 12 on both sides. Those 12s cancel, and now I have 3 over 12 equals y. But with fractions, I always want to try to reduce them And let's see, I think 3 goes into both of those things, 3 and 12. So really, I'm going to get y equals 3 divided by 3 is 1, 12 divided by 3 is 4, 1/4. Let's see, 18. Negative x equals 30. Whoa, what's going on there? If I see negative x, another way to write that is negative 1x equals 30. So I just write that. And now, let's, again, we're multiplying negative 1 times x. It's almost like there's a little multiplication dot there. It's invisible. And so we're going to divide by negative 1 on both sides. And so that leaves me with just x equals negative 30. That's going to be an important one. Anytime you have a negative x, divide by negative 1 and you make it positive x. Okay? Well, that was multiplication. Let's try some division ones now. Here we go. So for number 19, x divided by 3 equals 4. You're going to draw your line again. Now, to undo division, I need to multiply. So I want to put a multiplication dot to the left of the fraction bar, and then I'm going to put a 3 there. That's more on the top than the bottom, right? So it should line up closer with the x than with the other 3. But I have to do the same thing on the right side. And when I multiply by 3, that's going to cancel out with dividing by 3. And so we are left with, on the left side, just x. And negative 4 times 3 is negative 12. And again, try to check the answer, try it in your head. Negative 12 divided by 3 is negative 4. So we found the right answer. Okay, in number 20 here, I have 1/5 equals 2. So I'm going to, that's like division again. So I'm going to multiply by 5 on both sides. And that'll cancel those 5s out. And we just get 1y equals 10. 2 times 5 is 10. Now, 1y, that's just the same as y. So you don't need to do anything else there. We're good. Last problem. Number 21. Ooh, I have a negative fraction. Negative x over 2 equals 500. If you look at 19, it was just x over 3, and we multiplied by 3. So here, again, put your little line for the fraction, or the equal sign, but then I'm going to put a dot left of the fraction, and the number I should multiply by is negative 2, because that's really what's there. I've got the negative and then the 2. So I need to cancel those out, but whatever I do to the left, I should also do to the right, so I'm going to multiply by negative 2, and then we're left with x on the left equals negative 1,000. 500 times negative 2 would be negative 1,000 on the right. Okay, that is all for this video. Thanks for watching. Make sure you rewind, go back to anything you missed, and have a good one.